When you are doing IGCSE Edexcel physics, there is a topic that you have to do also, that is refraction, light, and waves. So today we are going to look into this topic with the question that you possibly can be asked and how you are supposed to approach each of the concept that is tested there. The first part that we're given here is a question, and we're supposed to state what is meant by the term refraction. We're going to say that refraction is actually the bending of a wave at the boundary as it moves from one optical medium to another. When light moves from one medium to another, light slows down, and in the process it bends towards the normal. We are also given a diagram, and then we are supposed to draw the path of ray of light in the water. The torch is directed at an angle of 45 degrees. So what is going to happen here? You're going to realize that as the ray of light moves from air into water, water is dense. So the ray of light is going to slow down the moment it strikes the boundary, and then it's going to bend towards the normal. So that when we are going to have our diagram here, we're going to draw this ray of light such that it bends towards the normal, and then we have the angle of refraction down here. We are told that to state the formula linking refractive index, angle of incidence, and the angle of refraction. Refractive index is the one that determines how much the ray of light is going to bend. The larger the refractive index, the more the ray of light is going to bend towards the normal. And the formula that we are going to use to write refractive index, remember, we are going to say that refractive index equals to the sine of angle of incidence divided by the sine of the angle of refraction. This formula can be written as n equals to sine I over sine r. I think this is very, very common, and this is very familiar to you. So as you're preparing for your exams, this is an area that you need to focus. Show that the refractive index of water is about 1.3. Remember, refractive index is a ratio, so it doesn't have units. So when you are told to determine the refractive index or to show that it's 1.3, this question is asking you to try to work out the refractive index using the information that is provided in order to come to a point you have it 1.3. So let us go ahead and try to work it out. Remember, we know that refractive index equals to sine I over sine r, and in our case sine I or I, angle of incidence, is 45 degrees, and the angle of refraction here is that 3 degrees, because that is, it was given on the diagram below here, the one that I've circled. Then if we work out this, we are going to get our answer as follows. You just make sure you are using your calculator properly in order to get the correct answer. So we have 1.31, and this is approximately 1.3, the one that we were supposed to show. The torch is moved below the surface of the water. Light from the torch is incident to the water surface at an angle greater than the critical angle. So if the torch is moved from its position and it's now directed from the water surface upwards, it means the ray of light will be moving from a dense medium to a less dense medium. And that's one of the conditions of total internal reflection. And if you look at this question, we are told that the angle of incidence in water is greater than the critical angle. So it means total internal reflection is going to occur at this particular point. But let us look at Roman 1. It says, explain the meaning of the term critical angle. Critical angle is a special angle, is a type of angle when is a type of angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. So let us write it down so that you can get to understand what I'm saying. Critical angle is the angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. So if you are given such a question, and that is what you are expected to write, and I can see here they said you may draw a diagram to help you answer. Of course, sometimes this diagram cannot award you a mark unless otherwise the examiner is fair enough, but it simplifies your explanation. So let us see, which diagram were you expected to draw? We can have a diagram like this, and the ray is moving from a dense medium to a less dense medium. So the angle at the top here is 90 degrees. So this is a less dense medium at the top and dense medium below. So since this ray is moving from a dense medium to less dense medium, then there is a point we have an angle of incidence in the dense medium when the angle of refraction is 90. So when you have angle of refraction in the less dense medium equal to 90, then the angle that is in the dense medium has a special name, and that special name is critical angle. Next, state the formula linking critical angle and the refractive index. So that is going to be sine of the critical angle equals to 1 over the refractive index. So this is very critical. We can use it in order to, maybe if you are given the refractive index, like in this question, you can be able to use that formula in order to come up with the critical angle. So we're going to, in order to find critical angle, we're going to find the sine inverse of 1 over the refractive index, and if you put that, you're going to get our answer as 50. Just let's use the calculator to check whether that's true. So the answer is 50.3 degrees. So we know the critical angle is 50 degrees. That is 50.3 degrees. The critical angle is very important because it enables us to know whether total internal reflection will take place or not. Now, when this ray of light is moving from water to air, when the angle of incidence, for instance, in this case here, we have 55 as the angle of incidence. So if this angle of incidence is 55 and it's more than the critical angle, then it means in that kind of scenario, refraction will not take place, but total internal reflection will occur. So complete the path of the ray of light. In order to complete this, you need to have that knowledge that I mentioned, that you have to compare. And most of the time this question is given when you have calculated critical angle, or when the critical angle is given, and then you have this type of question below asking you to draw the path. They are trying to check, do you really understand what is the meaning of critical angle and where does it help? So if you check here, our critical angle was 50.3, but the angle of incidence now here is 55. It means if this ray is directed to the boundary like that, it's not going to undergo refraction, but total internal reflection is going to take place, and this is then what we are going to have. So you see, conditions for total internal reflection are the angle of incidence should be greater than the critical angle. That's one of the conditions. And the second condition is the ray must be traveling from a dense medium to a less dense medium, which is the case. It's moving from water to air. So the two conditions are satisfied. And so this angle is greater than this one. 55 is greater than 50.5. So which means that in our case here, we're going to have total internal reflection, and then the angle that is going to run, the ray is going to move at an angle of 55 degrees like that. So this ray is going to be traveling in this 55 degrees in that particular direction. So that is how the ray of light is going to behave. Moving further, moving on, and if you are new to this channel, consider subscribing. Give this video a thumbs up. If you really benefited from this tutorial, you can leave a comment down below, just as a form of appreciation. You can also share this material or this particular tutorial to your friends who can also benefit from the same. Back to the main agenda of this video, we need to go down and look at this question. Here also you are supposed to define and state the term critical angle, and we already say that is the angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. And you can even draw a diagram, maybe a diagram using a semicircular glass block. If a ray is directed like that, you see it's directed in such a way that it's moving from glass. You see, at the point where this ray is meeting the circular glass, the curved part of the glass, the ray does not undergo any refraction because it meets the glass at 90 degrees. It's meet at that particular curve where that ray meets with the semicircular part of the glass. It's 90 degrees. So it goes straight into the glass without being refracted, and it hits where we have the normal at the central point. Then the ray is going to move along the flat surface such that it forms 90 degrees. So the angle that we have down here, the angle that we have here is called a critical angle when the angle at the top is 90 degrees. So this is another particular diagram you can be able to draw if asked. The diagram shows a cross-section through one of the binoculars. There are two glass prisms inside this half of the pair of binoculars. Complete the path of the ray as it travels through this half of pair of binoculars to the eye. Remember, the critical angle of glass is 42 degrees. So something that I need to remind you, this semicircular prism has got 45. So the moment the ray enters the glass through the flat surface, it meets it at 90 degrees, so it does not undergo any type of refraction. But the moment the ray goes straight to this particular end, it will be reflected such that it changes direction of 90 degrees. Yes, and this happened because the rays of light in the prisms undergoes total internal reflections. Because those angles of incidence are 45 degrees, which are more than the critical angle, then total internal reflection is going to take place. And most of the time you find the images formed by such kind of prisms are very clear because no energy of light is lost. I believe we are together up to that particular point, and the reflection took place, is total internal reflection, and then we can now move to the next part. We are told that name two additional pieces of instrument or equipment the student need for this particular experiment. The student wanted to study what? Refraction. The student wanted to study refraction. So instrument that are required for refraction are the glass block. We have a pencil there. Now we need also a protractor, and the protractor's purpose is to measure the angles, and we need also a ray box. A ray box will be acting as a source of light. The diagram shows the path of a ray of light as it travels towards and through the glass block. Draw the path of the ray of light when it leaves the glass block. Now let us move down and try to see. This is how the diagram looks like. So the first thing that you need to identify, or you need to do when you're given that kind of question, you need to draw the normals. So we need the normals at that particular point, and then we are going now to draw the ray of light at that particular point. Moving further, determine the angle of incidence and the angle of refraction at the point where the ray of light enters the glass block. So at this particular point, you are going to use the protractor to measure those angles, and this is how you are going to position. This is how you are going to position your protractor. Angle of incidence is the angle between the normal and the incident ray. So at that particular point, if you look at it keenly, this angle is 43 degrees. 43 degrees. So we need also to measure the angle of refraction. We shall shift it and adjust our protractor like that, and try to measure the angle formed here. Let's see that angle. Let's check that angle. What is it? That angle is 25 degrees. Angle formed between the ray and the normal that is drawn there. State the formula linking refractive index, angle of incidence, and the angle of refraction. In this case, we are going to write that because this is not the first time we are mentioning this. This is what we expect, and we're going to use that formula in order to work out the refractive index, substituting exactly what you are able to measure above. Don't use other values. Use the values that you got from the protractor when you did the reading. If you use different values, you are going to lose marks here. So this is going to reduce to, if we put this in a calculator, we're going to get 1.614, which is approximately 1.6. And remember, refractive index does not have units because this is a ratio. A teacher suggests that more accurate value of the refractive index can be found using graphical method. This method that we have used above here that has given us 1.6, we have just made use of two angles, 43 and 25. So chances are there could be errors, and that's just one point that you have used. So if you want to get a more accurate value, you need to do more measurements. You measure more angles of incidence, and then you measure corresponding angles of refraction. So you see, when you have more angles, accuracy is going to be guaranteed. Design a method to obtain a value of the refractive index of the glass block using the graph. Then you may draw a diagram to support your answer. Now let us go straight ahead and try to respond to this question. So given a question, what are you supposed to do? You should write using different angles of incidence, measure corresponding angles of refraction. So here what we are saying is you are going to direct a ray of light to the normal of the glass block, and then you shall measure different angles of incidence, and then you check what are the angles of refraction at those particular angles of incidence. Then this is exactly what you're going to do. Next step is plot a graph of sine I against sine R. Now after you have gotten pair of angles of incidence and angles of refraction, you are going to find sine I, you are going to find sine R in a table, and then you shall plot a graph of sine I against sine R. Then you see here we are going to get a straight line graph. This straight line graph indicates that as the angle of incidence increases, the angle of refraction also increases. Then there are some other things that we can be able to use this graph for. We can use this graph in order to find the refractive index that we had worked up there. So when you are using a graph to find the refractive index, you are going to work out the gradient of this line. And the gradient from here you can see is rise over run. Rise is sine I, run is sine R, then this is equal to the refractive index. This particular method is a bit accurate compared to just using one point. This method is more accurate because it involves many values, and also you can be able to identify anomalous points. Anomalous points are those values or those points or those readings you find, they are inconsistent with the rest, they are much above the rest. So if you are able to take many readings for this particular method, and then you identify there is one reading that is so big or so huge, it means that's an anomalous point, and then you are going to draw a line of best fit. So sometimes the reason as to why I mentioned this, in this particular question you were not supposed to have mentioned it, but what I'm saying is that sometimes you'll find questions asking you, why is this method accurate? It's because it involves more values, and at the same time you can be able to identify anomalous points which you can disregard in the process. Because when you have anomalous points, the way you deal with it is that you can repeat that point that is anomalous and see where the error was, or you can assume. And let me mention this because this is a question that also most of the time comes. When you are given a table of values and there is anomalous point, when you are told to work out the mean, don't use the anomalous point. Disregard it or ignore it. I believe that point is home. So we can be able to move to something else. This was not part of the question, so that's why I'm removing it. So the remaining part is what you are supposed to have answered. So we have a ray of light traveling all through medium here, and then we are told that when a very bright light shines on the transparent material, a small amount of light is reflected at point X. So you are supposed to draw the reflected ray from point X, and this is exactly what you are supposed to do. Now, diagram 1 shows what happens when light is incident on a piece of transparent material. We have a ray of light moving into point X. It goes through Y, Z, and then it is refracted on the other end, and then it emerges out of the transparent material. Roman 1, we are supposed to draw how the reflected ray will go from point X. And this is exactly what you will have. Measure the angle of refraction at point X. Measure the angle of refraction at point X. We're going to use a protractor. That's why during exams, physics exams, you must have your protractor, even if you are not told. Adjusting it properly, putting it there. Then if we measure the angle, let us zoom it a little bit so we see where that mark is. We check that is 32 degrees. Very good. Now, angle of refraction, 32 degrees. State the formula linking refractive index, angle of incidence, and angle of refraction. Just a walk in the park. This is a very, very good question. We've answered this before, so this is what we have to write. Next, show that the refractive index is about 1.7, meaning we are just going to work out the refractive index and check, is our answer 1.7? Let's see. Sine I over sine R, this gives us 1.69. If you round off, this becomes 1.7. State the formula linking refractive index and critical angle, and this is going to be sine of critical angle equals to 1 over n. And then in order to work out the critical angle, we are going to use the above formula that we have mentioned, and then we are going to say 1 over the critical or the refractive index, which is 1 over 1.7. And in order to find C, we are going to find the sine inverse of 1 over 1.7, and this is going to approximately be, use your calculator and check. What is your answer? Yes, 36 degrees is the critical angle. Explain the behavior of the light at point Y and Z. You can see at point Y and Z here, at point Y and Z here, this point here. What are you noticing there? Y and Z. Is the ray of light emerging out of the glass? No. So that means what? Total internal reflection is taking place. And for total internal reflection to take place, the ray must be traveling from dense medium to less dense medium. So if the ray was moving from X to Y, that is in the dense medium. But if it was to get out of Y towards the lower part, that's a less dense medium. So meaning here total internal reflection has occurred because the angle of incidence in the dense medium is greater than the critical angle. So no refraction took place. So what happens? This behavior is light has undergone what we call total internal reflection. Since the angle of incidence in the is greater than the critical angle, and the ray of light is moving from a dense medium to less dense medium. That's what you are supposed to respond at that point. Have you benefited from this tutorial? If you've benefited, leave a comment down below. Give this video a thumbs up, and also you can be able to subscribe. Conditions for total internal reflection: critical angle must be greater than the angle of incidence must be greater than the critical angle, and also the ray must be moving from a dense to less dense medium. Diagram 1 shows a light ray entering the glass prism. Now you see, we are given an angle of 40 degrees there, but that angle is not between the ray and the normal. So we have to find that angle there. Describe what happens to the ray of light when it enters the prism at point A. Look at point A. The ray is moving from air into the glass prism, meaning it's moving from a less dense material to a dense medium, which means that this ray is going to slow down. The speed of light is going to slow down, and then the ray bends towards the normal. That's why refraction takes place. Light slows down and bends towards the normal. And the reason is it's moving from a less dense medium to a dense medium. So you realize that if a ray is moving from a more dense medium to a less dense medium, it will bend away from the normal. But if it's moving from less dense towards towards the more dense medium, it will bend towards the normal. Like this one you see now, the angle of incidence outside is less than the angle that we have inside here. So the ray bends towards the normal there. State the name of the line XY. XY is the normal, the diagram that we are having at the top there. And we are supposed to state that formula already. We have mentioned that before. How to work it out, that's self-explanatory because we have done it before. That was 38.68. So if you round it up, you're going to get 29 degrees. Complete diagram 1 by continuing the path of light travel from point B. Now let's look at point B, but have it in mind that the critical angle is 90, or rather the critical angle is 39 degrees. You need to have that in mind. If the angle of incidence is more than 39, then total internal reflection will take place. But if it's not, refraction will occur. Let's go back to B. 39 degrees, this is our critical angle. So let's go back to the diagram. You can see now our XY is the normal. So at B, which angle are we having here? 90 minus 40, give me the answer, 50 degrees. So is this 50 degrees more than the critical angle? Yes. So if it's more than the critical angle, it means that total internal reflection will take place. 50 is more than the critical angle, which is down here. So going back to the diagram, this ray will travel like that, making 50 degrees, which means total internal reflection will take place. Our ray, when it gets out of the glass prism on this other end, it will move like that. It will bend away from the normal. But our normal is there, so it bends away from the normal like that. But this question was really focusing only at this particular region B. This is where if you didn't draw the other side, it doesn't matter. But the question was testing whether total internal reflection will take place or refraction will occur as well. The critical angle of the material of this prism is 55 degrees. Complete diagram 2 by continuing the path of the ray of light. Now, the angle of incidence now in this case is again 50, because 90 minus 50, rather, what am I saying? 90 minus 40, it will be 50. But there is this information we are provided. The critical angle is 55 degrees. And the angle of incidence in the dense medium is 50. You can see the angle of incidence is less than the critical angle. So it means in this now kind of scenario, total internal reflection will not take place. What will occur is refraction at that particular point, and that is the refracted ray, and this is R is the angle of refraction. So basically that's what you are supposed to draw to complete the ray. We are supposed to draw the normal where it's incident, the ray of light strikes the flat surface of the glass block. So the normal, we are going to draw it like that there. Some light from the incident ray passes into the glass block and it's refracted. So let us draw how is refraction going to take place. But remember, refraction is the bending of a wave. And now since the ray is moving from less medium to dense medium, which is glass, this ray is going to bend towards the normal like that. This is the refracted ray. Roman 3, we are told some light from the incident ray is reflected at the boundary. Draw the reflected ray of light. Let's check. Yes, it will travel like that, and that's the angle of reflection, and this is the reflected ray, and here this is the angle of reflection, and below here is the angle of refraction. Part B, a student investigates the refraction of light by the semicircular glass block using equipment in the photograph. Some of the equipment we have here, we have the glass block, semicircular glass block. We have a protractor. We have a pencil. We also have a ruler. And remember, the other requirement that we need is a ray box. We need a ray box which will act as a source of light, but it's not here. We know that the ray box is going to act as the source of light. Glass block is going to refract light. Protractor is going to be used to measure angles, and the ruler is going to be used to draw straight lines. Design an experiment to investigate how the angle of incidence of a ray of light affect the angle of refraction in the glass block. You may draw a diagram to help your answer. Now, in order to respond to this particular question, these are the following key aspect that you are mentioned. Trace an outline of a semicircular glass block, and you are going to do that on a piece of paper. Then you are going to direct a ray of light from the ray box, and then you are going to measure angles of incidence and then mark how the ray is going to get out. So direct a ray of light from the ray box to the glass block, and use a protractor to measure the angle of incidence. Mark where the ray of light exits the glass block, and then use a ruler to draw the refracted ray. Once you've done that, measure the angles of refraction, and then now using different angles of incidence, measure more corresponding angles of refraction. Then we're going now to fill a table and then plot a graph of sin I against sin R. If you draw this graph, you're going to get a straight line graph. And I've already mentioned that in previous sections that if you have this kind of graph, you can see that the sine of I and the sine of R increases like that. So it means as you increase the angle of incidence, the angle of refraction also increases. With this type of graph also, you can be able to work out the gradient, and the gradient of this graph or provides or correspond, or the gradient represents the refractive index of the material. As I've mentioned, this method is more accurate when determining the refractive index because it involves many values, and also if there are errors, you can be able to identify anomalous points. Welcome. Here we are going to have a discussion on magnetism and electromagnetism. Basic questions that you ought to know as you are preparing for exam. Remember to subscribe for more, as I'll be uploading more tutorials on physics and also in math. the main objective of this channel is to ensure that since the force, the thumb indicates the direction of the force, the direction. We also have the first finger, which represents the direction of the field, and the second finger represents the direction of the current. The next question here we are given, and we have part of a permanent magnet of a loudspeaker, and we are supposed to draw the magnetic field, and these are uniform magnetic field, and we need to understand that this uniform magnetic field have got a given condition that you must apply. They are straight. They usually have a uniform space between each other. They are uniformly spaced. You have to ensure when you're drawing this magnetic field, they are pointing from the north towards the south. Those are the conditions that you ought to follow when you are drawing uniform magnetic fields. And in this question, we are supposed to draw 3 of them, and this is what you are supposed to have as your final answer. Now, we need to move to the next part, and in this next part, we are told that describe the difference between alternating current and the flow of the electric current keeps on changing direction and also magnitude. Now, when current keep on flowing in such a manner that it keeps on changing direction and also size frequently, it means this is a type of current which we called alternating current or AC current. Keeps changing direction and size. While direct current is a current which usually moves in one direction. It flows in one direction, and this is a type of current that is provided by cells and batteries. Now, we're supposed to state the direction. We are supposed to state the point to the right. The thumb will point to the right, which means this is going to act. The peppercorn is going to vibrate towards the right. Explain why the loudspeaker produces a type of current which is called direct current. And then when we're using direct current, the field that are created do not change direction. Then this peppercorn is not going to vibrate. In that way, it's not going to work. And that's what we are supposed to state in this particular part. Welcome to another section. We're going to go further in magnetism and electromagnetism. The reason is they're going to repel each other because of having like poles. And this is according to the law of magnetism, that unlike poles attract, like poles repel. So that is the reason you are supposed to give this particular point. Now let me take you back to it. And for that reason, it's not going to be affected because it's made of plastic, which is a non-magnetic material. Non-magnetic that we're going to have here are going to be like that. Section of the fields moving to the, notice that they are going, the reading is going to actually increase because of the increase of the force of repulsion. So that is going to be the case. So the reading is going to increase, and the reading is going to reduce because now this case is going to cause the magnets to attract, and in that reason the reading is going to decrease. We need to identify some of the mistakes in each of the diagram here. B seems correct, so let's at this particular point see also there is a mistake. A correct answer is need also to remember some of the properties of magnetic fields. One of the property is that they point from the north to the south. Number 2, they should be continuous. There's no line there. And also do not cross each other. I think that's what we need to identify at that point. And where that magnet is strong, at that particular point. The correct answer is B in this case. Moving to the field between the poles, and C is going to give us, you can see this one is not, so this will give us this kind of fields. Yeah, so going to give us magnetic fields, which are for this particular part is C, and steel is the best material here, a magnet. Now let us identify that. We're going to put a bar magnet on a flat table and then sprinkle iron filings on it. So we're going to have a paper, then sprinkle iron filings. We are going to tap the paper gently so that those iron filings are going to react, and they will form a pattern, and this pattern is going to represent the fields of that. I'm going to use a plotting compass in order to determine the direction. So in the next part, actually, that force is going to be pointing towards, it's going to be a repulsive force that is acting in which direction? To the left. And the reason is and opposite reaction force to be 0.045. After collision, we are going to consider also the direction in this case, and then we are going to say this is going to be, this was 0.05 to the right, so this is going to be written as 0.05, 0.0 finals become 0.066 as that particular moment. You need to remember that force equals to change in momentum over the time taken, and in this case we have the change in momentum of a force of 0.35 newtons. Then it's going to be to the right. It's going to be to the right, like that. So here we're going to say the correct word is north, and there is attraction between, so talk of steel and the magnetic materials to the south. So iron is all magnetic material. Magnetic field, then it means that not pole, and now the fields must be uniformly distributed like that, pointing from the north. Okay, a knot is going to take place. So in this particular part, we have to say the iron ball is magnetized, hence attracted towards the magnet. An arrow on the diagram to show the direction of the weight. Alright, so the direction of the weight will be acting downwards, and ought to consider that particular point. Weight equals to mass times gravity, or gravitational field strength, which we're going to use in order to work out the equation below here. Now, in order to get the weight, I believe this is clear. We are given from 165 millinewtons. So weight is going to be that difference, which is going to divide this by 1000 with this. But remember, weight equals to mass times gravity, and then mass is going to be equal to weight divided. Able to substitute that formula into that, and then we are going to get our answer. That's what you are supposed to do. And the main reason as to why that happens is that the magnetic force increases, whereas the weight remains constant. Now, since the resultant force is going to increase, remember we said resultant force equals to magnetic force minus, having that part, the independent variable is actually the number of metal discs that we have here, because soft iron core is easily magnetized. So that is why that is the case, we need to move further to the next we'll use to find the direction of the magnetic field, and this is a plotting compass. I mentioned that in the previous section, so let us identify the mistakes in this part, and you realize that in each other at this given point, and then you need to understand that the lines should not cross each other, so they should not cross each other. Moving further to the next part is to describe what's meant by the term hard magnetic. Difficult to magnetize, but once magnetized, it retains its magnetism for long. It doesn't lose the magnet. I believe you are a bar magnet, and then the fact here is you have to indicate the direction of the fields in that the next area magnet, the fields of the magnet are actually going, voltage is induced in the conductor, and the amount of voltage induced depends on the strength of the magnet, also depends on the number of turns, depends on the speed at which the magnet is moved close to the conductor, and in that way we are going. Welcome to another session. Here we are going to talk about the topic pressure, which means that we shall be looking at some of the questions that you expect from this topic and how are you supposed to address them. Now, the first question here, we are told this: the diagram shows a cylinder containing propane gas. The propane gas is stored in the cylinder at a pressure of 1.03 times 10 raised to the power 6 pascals. Then we are supposed to state the formula linking pressure, force, and area. So in this case, we are supposed to indicate that pressure equals to force over area as written there. Roman 2, the cylinder has an internal surface area of 1.13. We're supposed to calculate the force exerted on the wall of this cylinder by propane gas. Now, we're going to make force the subject of the formula so that we can be able to work out this. So that in order to get this, we are going to say force equals to pressure times area. Then substituting pressure and area, we are going to work out this, and our answer is going to be yes. If we use our calculator, our answer is going to be, let us just work it out. If you write it in standard form, this is what we have. Next, we are supposed to explain why pressure exerted by propane gas is equal in all directions, and then say that this is because the particles of propane moves randomly, colliding with all walls of the container, exerting a force per unit area exerted is the same on all sides, hence pressure is the same in all sides. The graph shows how the pressure of a gas varies with its temperature. So we are supposed to describe how the graph can be used to show that there is a minimum value of temperature known as absolute zero. First, when you have plotted a graph of pressure against temperature in degrees Celsius, if you extend or extrapolate or make this line to cut the x-axis by just extending it, it means we are going to get the absolute temperature. So absolute zero is the temperature when the pressure of a gas is zero. At that given point, that gas has zero kinetic energy. So in order to show there is that, we need to extrapolate the line backwards so that it can be able to cut the x-axis. So let us just do it so that you can be able to see exactly what I'm trying to say. So that point, this point, is the absolute zero, and which is usually negative 273 degrees Celsius. If you plot a graph of pressure against temperature in Kelvin, it's a straight line that runs from the origin, meaning pressure and temperature in Kelvin are directly proportional like that. Going further now, we have another question. State the formula linking pressure difference, height, density, and gravitational field strength. And at this given point, we're going to say pressure equals to height times density times the gravitational field strength, H rho G. Height is the height of the liquid column, that is. The second part is the density of the liquid, and G is the gravitational field strength. And you need to remember those are the factors that affect pressure in liquids or fluids. The pressure difference between the surface of the water and the water at the bottom of the bottle is 2300 pascals. Calculate the depth of the water in the bottle. Then we're going to substitute and apply the formula that we have mentioned here, and we are supposed to have our answer in centimeters. Of course, now making H the subject of the formula and substituting our values. Density is 1000 times 10, then this becomes as 0.23 meters times 100 in order to get our answer in centimeters as 23 centimeters. And the next question here, the examiner was testing whether you understand how pressure varies with depth. We have three holes there. A, which is at the top, we have B, and C is at the same level with B. So Roman 1, we are supposed to draw a line on diagram 2 to show the path of water leaving the bottle from hole A. Now what you need to remember there is that at A pressure is least, so water will travel a least distance. So because the pressure at that given point is less, pressure in liquids depends on the depth. C is at the same level, so explain the path of water leaving bottle from hole A. So we are supposed to give the reason why is that the case, why is it the way we have drawn there. And we're going to say at point A there is least pressure, so water will experience a small force as it comes out of the hole, hence travels at a short distance, and that's exactly defined there. Moving further to Roman 3, hole C is at the same depth in the bottle as hole B, but on the opposite side. So we need to identify the fact that it's on the opposite side, but they are experiencing the same pressure. So since holes C and B are at the same level or depth, then pressure is the same. So meaning the water is going to come out at the same rate and it will cover the same distance. So the shape of the trajectory of water is going to remain the same, and it will just move like that, just like that. Diagram 1 shows ice cube floating at rest in the beaker, so it's not moving up or down, it's at rest, meaning the resultant force is 0. State the value of the resultant force at that point. So since it's not moving, the resultant force at that point is actually 0. Oh, there is this question also. We were supposed to suggest why there is a hole in the cup. That one is to allow air to flow into the container so that atmospheric pressure can be able to act on the surface of water there. So once air is coming in, water can be able to flow out. And for that reason now atmospheric pressure will be acting on the top of the surface of water, so that there is a balance between inside and outside pressure. I believe that is well understood. So we can be able to move to question 3, whereby we are told that there is a ice cube that is resting on the water surface, and you see that it's resting, so it means it's not moving. So the resultant force is 0 at this given point. the two forces are balanced, then not moving, so meaning that the resultant force is 0. State the formula linking pressure difference, height, density, and gravitational field strength is a question that you also expect to have. So you need to know that it's H rho G like that. Moving to the next part here, we are supposed to work out the pressure, and then our answer is going to be 410 pascals, which is approximately 400 pascals. But the formula linking pressure, force, and area, this is pressure in solids, is as given there. Then we can be able to apply it in order to work out the force in this case, and then our F is going to be equal to 400 times 0.0017, and our final answer becomes 0.68 newtons. Explain, let's move down here. Explain why the ice cube will accelerate upwards when force X is removed. When force X is removed, then the upthrust force will be greater than the weight. Then the resultant forces will be acting upwards, and that's why we are supposed to state there. The upward force is greater than the weight of the cube, hence the resultant forces will be acting upward, hence it will accelerate upward. Those are the reasons. And if you are finding value from this tutorial, please consider subscribing. Also, you can be able to share this video to your friends, also that they can be able to benefit as well. Moving further, let's check if there is anything left. Remember to subscribe for more. There is another section here. I just felt that I have to share this with you. How do gases exert pressure in a container? This is a very, very important question that you have to know for the purpose of your exam. Remember, a gas is made of molecules, and these molecules keep on moving in random motion, and in the process they collide with the walls of the container, exerting a force, and the force per unit area is pressure. So we are going to say gases are made of molecules which moves in a continuous random motion. They collide with the walls, exerting a force, and force per unit area is pressure. Now, how does temperature or heat, when heat is introduced, how does it affect the pressure in a gas? So we are going increases what? Increasing temperature increases the kinetic energy of the gas particles, making them vibrate more frequently and exerting more force, hence increasing pressure. I believe you've benefited. I believe you've learned something new, and don't forget to subscribe. See you in the next video. Welcome to another tutorial. Here we're going to look at some of the questions that you expect to prepare on as far as paper 2 is concerned. This is just a concept paper that enable you to prepare for your paper 2 exam very well, and I wish you the best for this coming exam, so that you can be able to achieve your dreams. Before I start, if you are new to this channel, consider subscribing so that anytime I upload a video like this, you get notified. Now we need to start with the first question. You are told that the student measures the temperature of the sample of water during heating. The sample of water has a mass of 0.45 kgs. Calculate the energy to increase the temperature of water from 16 degrees Celsius to 100 degrees Celsius. And when you are given a question like this, you must be provided with the specific heat capacity. And for this case, the specific heat capacity is 4,200 joules per kg per degree Celsius. Questions like this will not miss in paper 2, and you can be asked to work out the quantity of heat, you can be asked to work out the mass, you can be asked to work out the temperature or change in temperature. Then the most important formula that you ought to remember is this formula that we are going to mention here. And of course, change in heat equals to mass times specific heat capacity times temperature change. And this change in temperature, change in theta, is usually the final temperature with 100 degrees Celsius minus 16 degrees Celsius. So our mass is given here, specific capacity is given, so we need to work out change in temperature. And this, our change in temperature in this case is 84 degrees Celsius. So having obtained that, we can now be able to go straight and put that in our calculator so that we can be able to get our answer, and then we can be able to write it down here. Now moving to the next part, we are told that the diagram shows the temperature time graph for a sample of water, and we are supposed to answer a few questions here. Use the graph to determine time taken from when the water started to boil to when the water stopped boiling. So remember, at boiling point, at that given point, when there is a change of state, there is no change in temperature. So where you have the flat graph, it means that's where boiling is taking place. So we are supposed to go straight and identify this point and this point so that we can be able to check the temperature here, and also this is 7.4, and then to get the time taken here is 4.4 minutes. And moving to the next one, this question is testing whether you understand the formula energy equals to power times time. Then we are supposed to work out the energy that was required for the water to boil, and in that case we have the power times 4.4. Remember, 4.4 was minutes and our time has to be in seconds, so that's why you can see I'm multiplying by 60 so that we can be able to have the time in seconds. And if we work out this, can you check with me, what are you getting? We are going to get our answer as 580,800 as the final answer at this given point. Give the reason why the liquid water should be stirred during the heating. Remember, we need heat distributed throughout the liquid, the entire part, so that when you are measuring the temperature, it can give you an accurate answer, which means that you can be able to determine the heat has been distributed in this liquid. So in order to ensure that heat has been distributed, we are going to stir the liquid so that this heat is uniformly distributed throughout the liquid. After finishing the experiment, the student removes water and the heater and places the container of water into a freezer, and then we are told that we need to so that we can be able to draw the temperature graph. How does it behave from 38 degrees Celsius to when the ice is negative 20 degrees Celsius? So you are going to see that temperature is going to decrease, and then at 0, water, because we are told the water becomes ice at 0 degrees Celsius. So there is change of state at 0 degrees Celsius until all the water has been converted to ice. So we are going to have a flat part at this given point. And then once all the ice has been formed, or the water has been converted to ice, we are going to have now the ice losing the heat to negative 20 degrees Celsius. So which means at this particular region here, this is water losing heat, and here water is changing state from liquid to solid, and at this point the ice is cooling further, so meaning there is also temperature change at that given point. If you are finding value, please consider subscribing, and also you can leave a comment down below on if the tutorial was helpful to you. Now moving further to the next part, we are going to talk about pressure, and we are told that propane gas is stored in the cylinder, at a pressure of 1.03 times 10 raised to the power 6 pascals. State the formula linking pressure, force, and area. And when you are given this question, it means you are writing the formula pressure equals to force over area. Remember, force should be Newton and the area should be in a meter square. The cylinder has internal surface area of 1.13 meter square. Work out the force exerted on the walls of the cylinder by propane gas. So when you are given force, pressure, you are given area, we can be able to rearrange the initial formula that we are written so that we can have pressure is that, but now force equals pressure times area. Now we can be able to substitute the values, and our answer now can be given as what? Yes, that's what you are expected to get. And the next part, we are supposed to explain why pressure exerted by propane gas increases when the cylinder is transferred into a warmer room. Now, we know that the propane gas, all gases have molecules, and these molecules are in a continuous random motion. They collide with the walls of the container. Now, how does now increased temperature affect the pressure? Pressure increases. Now, in this question, we are supposed to justify why does pressure increase. Now, remember, when you move this cylinder to a warmer room, temperature increases. And when temperature increases, it increases the kinetic energy. So look at the situation here. We have this kind of animation here. We have particles vibrating in their fixed position. That is a solid. Solid particles vibrate in fixed positions. Yes, you can see they vibrate. When the heat is continuing to heat this solid, now the particles are free to move, so they collide. Now in gaseous state, they collide with the walls of the container. And you see, as temperature is increasing, the pressure gauge is also increasing because the number of collisions with the walls increases. Yeah, just look at the way the particles, now when temperature increases, the particles collide faster with the walls. You see, they're moving very fast, so pressure increases. You can see that. So in this particular question, this is the concept that you are supposed to talk about, that increase in temperature increases the kinetic energy of the gases. And as the kinetic energy, the number of collisions per unit area on the walls of the cylinder increases, and this results to an increase of pressure. So there are other factors that can increase pressure in gases, of course. We can talk of reducing volume, increases the number of collision because there is a small area over which these particles vibrate. And you can also get questions like that. So if you cool a gas, the kinetic energy decreases and also pressure decreases. Moving to part B, given that the volume of propane gas is 1.03 meter cubic at pressure of 1.03 times 10 raised to power 6, that should be power 6. Calculate the pressure of the gas if propane gas expands and its new volume becomes 2.45. Now you see, when volume actually increases, pressure is going to decrease. But in order to answer this question, we are going to use the formula P1 times V1 equals to P2 times V2. Then we can be able to make P2 the subject because we are finding P2, and then substitute what we have. If we work it out, we are going to get our answers 4.33 times 10 raised to the power 5 pascals. And then you transfer it here so that you can make the examiner happy. There is no extra mark for that, but that is meant to have a good rapport with the examiner. Moving to electromagnetic induction, the most interesting concept in physics. Now we go to question 3 here. We're told the diagram shows a transformer that has efficiency of 100%. So when we're told that efficiency is 100%, it means that power input equals to the power output. Unfortunately, that is the first question. state the equation linking input power and output power of the transformer. Here we are going to say power in equals power out. Don't forget that. That's the first question that you need to remember as far as transformer is concerned. But power is given by voltage times current, which is P equals to VI. And we're going now to calculate the output current in the transformer. Now, using power in, power out, we can be able to rewrite this as V in times I in equals to V out times I out. And then in, this is the primary coil, and out, we're going to use the secondary coil. Remember, we're using out because at the secondary coil, that is where now the power is going to be taken out of the transformer. Now we need to check the voltage in the primary coil and the current in the primary coil. That's well demarcated there. That is 230 volts, so that we can be able to work output current. So output current, now we can be able to make I out the subject, and this is going to become 230 times 2 divided by 110. So if we work out this, what do we get? Use your calculator here. This becomes 4.18. So in simple terms, what I'm trying to say is, be prepared to do such kind of equation. You have to know how to work out this. Look at this question as if your life depends on it. Moving to part B, Roman 1, state the equation linking input voltage, output voltage, and turn ratio of the transformer. So here we are going to write two equations that represent this. This one can be written as V voltage in the primary coil or voltage in the secondary coil equals to number of turns in the primary coil over number of turns in the secondary coil. Or it can also be given as number of turns in the secondary coil over number of turns in the primary coil equals to voltage in the secondary coil over voltage in the primary coil. And I'm going to use this second part so that I can be able to use it to answer Roman 2, because you are supposed to calculate the number of turns on the secondary coil of the transformer, so that we can be able to use the number of turn here, number of turn that we are looking the secondary coil. We have everything. Then we need to substitute all that we have and then make NS the subject of the formula, and this becomes that. And finally we have approximately what? Use your calculator here and tell me what you got. I got 573.9, and I can be able to write this as, let me just try to write this down here, 573.9. Just can give it like that, and then we can be able to proceed to the next question. Another part, explain how a step down transformer works. We are talking of a step down transformer. Do you know the purpose of a step down transformer? A step down transformer is a transformer that reduces voltage. And something else that you need to understand, you need to know these two transformers. When we are talking about a step down transformer and a step up transformer, they have distinctions in terms of the number of turns. So a step down transformer reduces voltage, and when alternating current flows through the primary coil, magnetic fields which are constantly changing directions are created or formed, and these created magnetic fields are linked to the secondary coil by the soft iron core. As the varying magnetic fields cut across the secondary coil, a voltage is induced in the secondary coil, which results to the flow of a current in the secondary coil. So this is exactly what you are supposed to have stated in this particular question. And remember, since there are fewer turns in the secondary coil, we're going to have less voltage induced. So that is why it qualifies to be, a step down transformer, because we have fewer turns in the secondary coil than the primary coil. Question number 4. Here I brought the concept of principle of moments, and you ought to prepare as well how to answer questions on principle of moments. And you can see here we are told that a meter rule is balanced on a pivot by 3 vertical forces as shown in the diagram below. Then we supposed to define the center of gravity. At the center of an object, you can be able to balance an object, and that object will remain at equilibrium, will remain at balance, will not topple to any side. So which means the center of gravity is a point where much of the mass of the object is concentrated. So we are going to identify that, and we are going to say that center of gravity can be defined as, that's the COG, of course, that's where the COG is, because we are told it was a meter rule, it is 100 meters. So the center is going to be where we have the 50 centimeter mark. One part we have 40, we have 10, then that makes 50, so the COG is at that point. And then now we can go ahead and write this definition. This is a point where the mass of an object is concentrated. Show that the moment of the 50 Newton, that dot is misplaced. It should be 50 newtons. It's 50 newtons. Let me change that. Moment equals to force times perpendicular distance. That is the formula we shall use to work out the moment. But we need to show that, yeah, this is 50 newtons. Yes, you now have changed it. On the diagram, don't look at the equation because that was a mistake. So it should be 50 newtons. There we have a force, we have 40 centimeters and 10 centimeters and 20 newtons. So we are supposed to show that the moment of 50 newton about the pivot is 2000 Newton centimeter. So we are going to say force times perpendicular distance will enable us to work out the moment. This is going to be 50 times the distance. The distance is 40 centimeters. So if we multiply here, we are going to have 50 by 40, and this is going to give us 2000 Newton centimeter. Next, using the principle of moments, calculate the force F for the meter rule to remain at equilibrium. Now, I want you to be very, very keen here. The pivot is placed at 40 centimeter mark from one end. And when you are doing this kind of questions, I want you to be careful, because all the distances that we are talking about here are measured from where the force is to where the pivot is. So we have force F and 20 newtons. They are on one side, on the same side of the pivot. And therefore, these two forces are going to give us a clockwise moment. So if we want to work out the moment due to these forces, we are going to say clockwise moment equals to anti-clockwise moments. Now at equilibrium, at balance, the two moments must be equal. Therefore, we need to work out a clockwise moment, and since we had worked out anti-clockwise moment, which is in Roman 2, we are going to equate them in order to work out F. But under the clockwise moment, we have two forces, so we are going to have the sum of the two moments, which means that we are going to say here clockwise moment, sum of clockwise moment equals to this one here, 20 Newton times 10, which is going to give us 200, of course. And then now we have another moment from the pivot to where the force is. And remember, from the pivot to where F is, that is going to be 60 centimeter. You need to be keen on that. That is going to be 60 centimeter, because all the distances are measured from where the force is to where the pivot is. I'm repeating that because that's the area most of the students, most of you, make mistakes. So having that is F times 60, and then we can be able to write this as 200 plus 60F. Then we can be able now to equate this to the anti-clockwise moment, which was 2000, and then this is going to be taken on the other side of the equal sign, and this is going to be 60F equals to 1800 divided by 60 both sides. We shall have our F equals to what? Equals to 30 newtons. Another question that is usually asked is what's the magnitude of the normal reaction force at the pivot? And the concept that we shall use to find that is that at equilibrium, downward forces equal to upward forces. We have downward forces that are acting on the pivot. On both sides, we have 50, we have 20 Newton, we have also 30 Newton that we have obtained. So all these forces, F, 20 Newton and 50 Newtons, are acting downward. And the force that is supporting these forces, that is preventing from the meter rule going down, is the pivot force that is acting upward. So the pivot force will be acting upward. So normal reaction force is going to be 50 plus 20 plus that, which is 100 newtons. So you see the normal reaction will be acting upward like that. So meaning some questions in some exams you can be asked to indicate the direction of the normal reaction. It will be acting upward, and that is 100 newtons. Going further to the next concept so that we can be able to check, we are talking of electromagnetic induction. We are told when a conductor carrying current is placed in a magnetic field, it experiences a force when the switch is closed. This is a concept that we learned in class, and many times most students find problems in answering questions like this. We are supposed to explain why that happens. Why does a conductor experience a force when it's placed in a magnetic field? If this is one of the questions that you usually find difficult, a question that you have found difficulty answering here, I need to give you a very precise answer that you are supposed to give. One of the facts that you need to remember: when current is flowing through a conductor, when current is flowing through this conductor, magnetic fields are created around the conductor due to the flow of current. And these magnetic fields that are created interact with the magnetic fields of the permanent magnet. So we are having two pair of fields that are acting there. Magnetic fields due to the flow of current, which are concentric and are acting around the conductor. And also we are having the fields of the permanent magnet. So we're having a set of two fields which are going to pull and push each other. Remember, when you have magnets, they push and pull each other because of the interaction of the field. And that's the same thing that is happening here. So when this happens, when current flows through the conductor, magnetic fields are created around the conductor. These created magnetic fields around the conductor are going to interact with the fields of the permanent magnet. Hence, the conductor experiences a force. That's what you are supposed to say in this particular question. Part B, you are supposed to state two ways in which this force can be increased. How can you be able to increase this force? Remember, this force is as a result of the fields of the permanent magnet, and also as a result of a flow of current. So in that way, we are going to say that we can be able to increase this by two ways. Number one, I needed to also mention this, that you can be able to determine the direction of this force by Fleming's left-hand rule. Now, by increasing the amount of current in the conductor, you are going to increase the force, and also by using stronger magnets, which are going to provide strong magnetic fields. Next, we're supposed to state two ways in which this force can be made to act in the opposite direction. One way is to reverse the direction of, to reverse the polarity, reversing the poles of the magnet, and also you can be able to reverse the direction of current in order to change the direction of motion of the force. So by reversing the terminals of the cells and by reversing the poles of the magnets, that will affect the direction in which the force is going to move. Well, also you need to remember, when both of them, when the poles and the terminals are reversed, both of them, there is no effect in the change of the motion. Explain the effect of the conductor on the conductor if an alternating source is used. In the previous section, we used direct current. Now, when we use alternating current, there is something that is going to happen. Remember, alternating current keeps on changing size and direction. So the fields that are going to be created when using alternating current are going to be changing size, magnitude, and direction. So the conductor will vibrate up and down, and this is because the fields created by the alternating current are constantly changing size and direction. So the conductor will vibrate up and down. Now we're going to talk about this simple electric motor. These are also some of the questions that are usually tested. We are supposed to identify a few parts that we have here. We have a metal or graphite brush in contact, and this is for conductivity and also reducing friction, because these commutator are sliding. The commutator are there to reverse the direction of the current so that the motor continue moving in the same direction. We have also the permanent fields, the permanent magnets, which are going to produce the magnetic fields. And we have also the flow of current in this loop, and when current flows through this loop, magnetic fields are created around that loop. Now you see, since we also have fields of the permanent magnet, the two magnetic fields, magnetic fields due to the flow of current in the coil, and the fields due to the permanent magnet, they are going to interact, and then there is a force, as we had mentioned earlier. So we need to try to talk about this, and I want to identify this coil A, B, C, and D. And you can see in one arm, currents moving up, on AB, currents moving towards us. Now explain how an electric motor works. Now, when electric motor switch is switched on, current flows through the coil. Now we have fields, of course, created here, and there is this magnetic field of the permanent magnet. So when current flows through this, AB is going to experience an upward force. When current flows through the coil, AB magnetic fields are created around it, and those magnetic fields interact with the magnetic fields of the permanent magnet. Hence, the part AB is going to experience an upward force, while CD is going to experience a downward force. Now we are going to have a rotational motion at the loop here. Now you see, this is another part. We can talk of electric motor. We can also be tested on DC generator. Now you see, we have a magnet, we have a bulb somewhere there. So if we happen to rotate this loop, the loop is going to cut across the magnetic fields. As it rotates, it will be cutting across the magnetic field. Now when the loop cut across the magnetic field, electric current is generated in the conductor. A generator produces current, but a motor uses current to bring about rotational motion. So when a wire cuts across magnetic field, a voltage is induced in a wire through electromagnetic induction. Now, stage 3 modification that can increase the speed of the rotating coil. Now, to increase the speed, we can be able to do that using a stronger magnet, also by using more coils, or we can increase it by increasing the amount of current in the coil. That's what we are supposed to do. We are told the diagram shows a loop of wire connected to a power supply, and we're supposed to describe how to find the magnetic field produced by the loop of wire. The easiest way to describe the magnetic fields forms around this piece of wire or loop of wire is by using iron filings. We are going to sprinkle iron filings on the cardboard. Now, once we have sprinkled these iron filings, we are going to tap the cardboard. Then once you tap the cardboard, these iron filings are going to arrange themselves in a regular pattern. And this pattern now is the one that displays or represents the arrangement of the magnetic fields around this. They are circular, concentric, and they have a very beautiful pattern like that. Now, the next thing that you ought to do in order to get your final mark, you need also to indicate how do you determine the direction of the magnetic fields. So to determine the direction of the magnetic fields, of course, you are going to use a plotting compass. Now, this is what you are supposed to write: sprinkle iron filings on the cardboard. And next, you need to tap the cardboard gently. And then what do you notice? The iron filings are going to rearrange themselves to form a regular pattern. This pattern that is formed around the conductor represents the magnetic fields due to the flow of current. Now, to determine the direction of the current, we are going to use plotting compass in order to determine the direction of current. I believe you are getting value from this video. Please consider subscribing. Even though maybe you are doing your final exams, just the best thing, the best present you can give me as per now is by just subscribing and liking this video, and so that YouTube can be able to recommend this video to others. Even if it's not going to be of help later on, just please subscribe that, give me that present of subscription. I will also be motivated to create more for others, and at the same time, this channel is going to be a concoction of also A-level videos. So I believe later on you are going also to benefit. We are going to have maths videos, physics videos for A levels. So please, that's why I'm requesting you give me that subscription. The next part, you are supposed to draw the way the patterns are around here. That's what we're going to have. And then we're going to have the direction of the field, which you can be able to use right hand grip rule. Right hand grip rule is the rule that you use to determine the direction of the fields around this. Now, question number 6, we are told a student uses an oscilloscope to determine the speed of sound. So meaning you have to prepare on how to determine speed of sound using different experiments to determine speed of sound. This is one of them, using a CRO. There are other experiments like using echo method, whereby you stand a given distance away from the wall you produce a sound and you determine how long it takes to hear the echo. And when you're using that experiment, you need to use a meter rule or a tape measure to measure the distance from where the wall is to where your position is. And also you need to have a stopwatch to determine how long it takes to hear the sound. Now, at that given point, you are going to use the formula speed equals to 2 times distance over time, because sound travels twice the distance. It travels to that point where the wall is, then back. Another experiment for sound determination is when two people standing distances apart, a given distance, maybe 100 meters is the standard distance when you're using that method. Two people standing 100 meters apart, one produces the sound and the other also stops a stopwatch once he or she hears the sound produced. Errors in those experiments can be reaction time, error due to stopping the stopwatch, or error due to measuring the distance wrongly. That can also be tested. Now back into this question using a CRO, we are having the y direction. The y direction is giving us the amplitude. X direction is going to enable us to get the periodic time. Time is on the x direction, and remember here we have time in milliseconds. 1 square is 1 millisecond. What does that mean? 1 millisecond is the same as 1 divided by 1000. So that you work out the time in seconds, you need to divide 1 by 1000. Now the student uses 2 microphones. A microphone is also required here, and some question you may find they are asking you which other apparatus is required. At that given point, when you're given that question, additional instrument is a microphone, which is mentioned here. All right. So when this experiment is performed, 2 microphones are used like that, and now when you measure the distance between the microphone, that represents the wavelength. Now we are supposed to state the formula linking speed, frequency, and the wavelength of a wave, and we're going to say speed equals to frequency times wavelength. Frequency has to be in hertz, and wavelength has to be in meters. You have to remember that. Always use the oscilloscope to calculate the speed of the wave. We are using the formula that we have stated. Now we need to work out the periodic time, and period time is time for one complete oscillation, one complete cycle. So we have one complete cycle when we have 4 squares. So times 1 millisecond, that becomes 4 times 1 millisecond, that becomes 4 milliseconds. That's the periodic time. But remember, our time is in milliseconds. So what are we going to do to get the time in seconds? We're going to divide by 1000. So our periodic time for one complete cycle is 0.04 seconds, and we know that frequency is 1 over period, which is going to be approximately 250 hertz. Now we can go back and work out the speed. Our speed is frequency times wavelength, which is going to be 250 times wavelength, which is 1.4. It was given there, and when you work out that becomes 350 meters per second. I believe you've understood how to work out such questions. Please comment down below, give this video a like. Differentiate between renewable and non-renewable energy resources. When we are talking about renewable and non-renewable energy resources, these are 2 energy resources that we discussed in our lessons. And we say that energy resources that do not deplete, that can never be finished, that can never be used up, are renewable energy resources, which we can define as energy resources which can be replenished, can be replenished once used. They are regenerated naturally. They are never used up. So examples include solar, we can talk of geothermal, we can talk of hydroelectric power, we can talk of wind power, we can talk of tidal power. So these are the renewables. So you need to understand this definition, and also you need to understand advantages involved in these type of energy resources. Now we can have a talk of non-renewable energy resources, which are type of resources which cannot be readily replaced once used up. Once you use them, it takes a longer period of time to replace them, or you cannot even replace them. Examples include nuclear energy, coal, we talk of natural gas, we talk of fossil fuels, and many others. Yeah. Then you also need to understand advantages and disadvantages of using this non-renewable to the environment, and also the advantages. So basically you need to go straight and check those advantages, disadvantages, and advantages before you sit for your exam. The photograph shows Green Georges Dam in China, one of the largest hydroelectric power stations on Earth. State 2 advantages of generating electricity using electric power station. What are the advantages? Number one, it's sustainable and is renewable form of energy. Yeah, is renewable and sustainable. We can talk is clean and environmental friendly. It does not produce harmful gases. It does not harm the environment. So it's clean and environmental friendly. It does not produce CO2. That's one of the advantages. It does not contribute to global warming because that does not produce greenhouse gases. It can produce energy to meet the drastic and immediate demands. Yeah, we can also talk about it can generate. It has a low maintenance cost. So even though the capital of starting an hydroelectric power station is high, but now after you have built it, after the country has built it, it has low maintenance costs. And it has a long span. It can serve people for a long period of time. Okay, let's move to cosmology. Let's move to another astrophysics concept. Now, do you know the origin of the universe? Do you know how the universe began? The universe has a very long history. There are different theories that explain how the universe began. Right from our religion, our traditions, and science also have its own perspective, how the universe began. In the specification, we are going to base our argument in the Big Bang Theory. Big Bang Theory claims that the universe began about 13.8 billion years ago, and the universe expanded from a single incredibly single short small dense point, and that point was very hot, so it expanded to become the universe we have. So Big Bang Theory still claims that the universe is still expanding. So what's the fate of our universe? If something is expanding and it continues to expand, it will reach a point where that thing's going to explode. So I believe we are going to live and see that happen. But for today, I want us to talk about how cosmic microwave background radiation CMBR supports Big Bang Theory. So when you're given a question to show how the presence of cosmic microwave background radiation support Big Bang Theory, what are you going to say? I believe this is a candidate question. This is a pregnant question that can be given birth in an exam. So according to Big Bang Theory, the universe originated from a hot, dense point that expanded to become a universe. detection of cosmic microwave background radiations of short wavelengths spreading from all directions serves an evidence by the claim that they might have an indication that they might have been created during Big Bang Theory, during the explosion. So since we are able to detect this microwave background, these cosmic microwave background radiations everywhere in the universe, spreading in all directions, so we tend to imagine where they might have been created during the explosion. So this is the evidence. Part B, you are supposed to describe how the size and temperature of the universe has changed since Big Bang Theory. We say that the universe, according to Big Bang, the universe originated from a small, hot, dense point, which expanded, and the universe is still expanding. So how does that affect the size and the temperature of the universe? So initially, the universe was incredibly small and dense. Since then, the universe has expanded and cooled down. So this results to the increase in size of the universe and decrease in temperature. Part C, discuss two pieces of evidence that supports Big Bang Theory. We have already mentioned them, but I brought this question up so that maybe one of them can be asked, so that you know exactly how to approach it. When I'm putting these questions, I'm just giving a concept so that when a question is asked, you know how to approach it. It also can be asked like this. And we have two evidence. We have the existence of cosmic microwave background radiations, and also we have the redshift that is observed from distant galaxies. So existence of cosmic microwave background radiations, CMBR, appears to be the same everywhere and acts in all directions. They might have been originated from Big Bang Theory, so during that explosion. So when we see that, we can be able to see that indeed the universe might have originated from Big Bang Theory. The next evidence you are to give is the redshift that is observed from light emitted by distant galaxies. So this redshift indicates that the galaxy is moving away, which means that the universe is still expanding. And remember, this is an assertion. This is a claim of Big Bang Theory. Big Bang Theory says that the universe is still expanding. So when you see the redshift, that galaxies are moving, it means that still the universe is expanding. And indeed, we can be able to confirm that. Next particular question that you can be asked in order to answer, we talk about Doppler equation, Doppler effect equation. Now, we are told that hydrogen gas in the lab on Earth emits light with a wavelength of 605 nanometer. A distant galaxy contains hydrogen, which emits light on the same wavelength. Now, it emits in the same wavelength, but when that wavelength is observed from the Earth, it's seen to be 683 nanometer. So you can see there is a change, there is a shift in wavelength. Remember, Doppler effect is the change in frequency or change in wavelength when the observer is moving relative, when an object or when the source of the wave is moving relative to the observer. So since the universe is moving, we are going to detect a different wavelength. And now, in order to do that, we are observing the universe from Earth. Then we have the light that's emitted. So when you observe the wavelength of the light emitted by hydrogen has a different wavelength, and that is now Doppler effect. Doppler effect is the change in frequency or change in wavelength when the source of a wave is moving relative to the observer. So we are supposed to calculate the speed of this galaxy. Now we're going to use the formula change in wavelength over the reference wavelength equals to velocity or speed of the galaxy over the speed of light, which can be written like this. So the change in wavelength can be subtracted. We can be able to subtract these two in order to get the change in wavelength, which is going to become 78 nanometer. Now once we have that, we can be able to substitute into the formula. We have this is the reference wavelength, which is lambda naught, and we have the formula, and then we substitute. So the speed of the galaxy is going to be 3.87 times 10 raised to power 7 times 10 raised to power 7 meter per second as the speed of the galaxy. We have come to the end of this particular video. I believe you've gotten value. Continue revising for your exams, and my humble request is for you to give me that subscription. I'm going to prepare still another clip which will be dealing with topics that never appeared in paper 1, those topics that were not in paper 1. So there are high chances they will be tested. HR diagram, Hertzsprung-Russell diagrams, stars or evolution of stars. How do stars larger than the mass of the earth evolve? That's the next video I'm going to upload in a short while. Otherwise, all the best for your exams, and subscribe. If you want to check that video I've mentioned, I'm going to add a link in the description in this video. See you next time.